So we can start. So welcome to the session. I'm Chaminda. I'm the host of the event as well as a team member of FabLanka Foundation. So we are connected to the Zoom meeting on introduction to system engineering by Thiwanka. So he is connected from FabLab Makandura, where we just started our new FabLab operation. I'm connected from Colombo, from my home office, where we operate our FabLanka Foundation. In fact, just to introduce you, that FabLanka we started about 3 years ago as a social enterprise to educate and train people, skill development, and also even to lobby to the government of the new technology of and related technologies. So we have been doing different public awareness programs, training programs, and after starting the FabLab in Makandura last month, so we thought of having some kind of regular related knowledge sharing sessions. Some of you will be also resource persons in the future. We are planning to have ideally once a month 11 session. Now today, the idea is Thiwanka will be talking about system engineering for 30 to 40. Gretchen will be conducting or doing the discussion as well as introducing the speaker, and we will have a separate session on the discussions of you can contribute and share your ideas. We have about 1.5 hours. Now the Zoom is, we decided Zoom normally we use Google Hangout or Skype, but now with Zoom we can have up to 25 people connected with videos. Now the chat thing is, and also this is recordable. This is recorded now, so this will be available on YouTube. If you have any problems with being seen in the YouTube, you can keep your video, but I would recommend you to keep it on for for our reference. Now, disappointing thing is the free version is only up to 40 minutes. You get disconnected after 40 minutes because we have more people. If we have 2 people only, you can go infinitely. But now once you get disconnected, that's important. You go back to the same URL and you can connect back with the same URL. So therefore, we'll have we plan to have 2 sessions, but can go up to 3 sessions. So if you want to join later, the same URL, and reconnect back. Okay, in terms of logistics, keep your mic muted as far as you don't create noises, and also some people have already done. So normally keep your mic muted. You can explore different opportunities or options in the below. Okay, keep your mic muted. Somebody is speaking, and also there's a chat function. Now, when the discussion is going on, presentation is going on, you can start chatting, and Gretchen and other people will be reply to your messages. You can use the chat function, and also you can raise your hand. Most important thing is keep your mic muted, and when you speak, if you want to speak, raise your hand, or then you can also talk by unmuting. So without spending more time, I want to welcome you, but very briefly, if you can quickly introduce yourself, where you are connected from, what's your name, and what are you doing, that will be great. So we can start, for example, Chintaka.
Hello, yes. Hi all, I'm connecting from Scotland, and I recently completed my PhD in enterprise and entrepreneurship education. Well, that's briefly about me.
Okay. You can't take more than 1 minute. Okay. Thiwanka is there. This Gretchen, come back to Gretchen. Professor Patirana?
Hello, I'm Patirana, Professor of Production Engineering, University of Peradeniya. In fact, I had done my master's in automatic control and then PhD in mechanical engineering, and then back at Peradeniya continuing. And Dr. Chanaka is here.
Hi, I'm Thiwanka Samaranayake. I'm the present head of the department of, now it's called Manufacturing and Industrial Engineering. I did my PhD in Singapore in Manufacturing Systems Engineering. Yeah.
Okay, great. It's really great to have people like you, like real experts and people who are contributing. So it's really an honor. Prashant, unmute your mic.
All right, can you hear me now?
Yeah.
All right, Roshan here from Seattle, Washington. I'm not into the engineering area, but I got my PhD in bioanalytical chemistry, and currently I work at a pharmaceutical company called Bristol Myers Squibb here in Seattle. So I have expertise in bioprocess and bioanalytics, and especially in the process development area. So even though my background is not engineering, my work mostly related with the process development engineering side of things. So I work as a scientist, and I got some interest into this just by talking to Gresham, and I really appreciate what you guys do here. I just wanted to stay in touch.
Okay, thank you very much, Roshan. It's really a pleasure to have you and also know you. So we have three guys here. They are our FabLab current kind of trainees, but they are going to be a trainer. So you see three young guys under Supun's computer. They are people from FabLab Makandura. Buddhika, did you introduce yourself?
Hello, I'm Buddhika Jayasene. So I too got my PhD in mechanical engineering from Singapore, and then I moved to USA. Currently, I'm working in biomedical device industry.
Okay, and also he's a co-founder of FabLanka. Thank you, Buddhika. Dimutu?
Hello, sir. How are you?
Very good. Please introduce yourself quickly.
Right. I'm Dimutu Dugamusurya. I'm actually a student of Mr. Chaminda Hettiarachchi. I did my MBA in Colombo University, specialized in marketing. I was head of corporate sales in Multilac recently, but now I'm working as a lecturer and a corporate trainer. So thank you very much for joining us.
Okay, thank you very much. Sri, good morning, my neighbor. Unmute please. You might be muted.
Yes, okay.
Yeah.
Can you hear me now?
Yes, go ahead.
I'm Kitsiri Vijayasundara. I'm a very old engineer compared to the young people whom I am seeing on the screen. I left Peradeniya in 1977.
My God.
So that was 40 years ago. We are celebrating our 40th year of graduation now. But I have been in the industry, and I consider myself as up to date on management of manufacture more than technology of manufacture. Of course, I am familiar with the 3D printing, which we have been talking about some time ago. So I'm very happy to join this because systems engineering is something very much we should have. Once I got a compliment from my own sister saying that only engineers can think in system, has system thinking. Probably that is because of our training.
Okay, thank you very much. Nice to have you back. Sandun Ranavira? Hello, Sandun.
Hi, this is Sandun, joining from Seattle, Washington, USA. I have a degree in mechanical engineering, and currently I work in the aerospace industry. And I'm also doing a software engineering degree.
Okay, thank you very much, Sandun. Also, co-kind of starter and international advisor, Sandun. Welcome. Aspire, this is Aspire TV. Galocious. It's Mikey muted. And also, I don't see you.
Are you calling?
Yeah. The room came and went back.
I Yeah, I'm Aloysius Hettiarachchi.
Yes.
Can I introduce myself?
Yeah, go ahead.
Okay, I'm a very senior engineer. I think I'm the most senior out of the lot I have seen so far.
Okay.
So I'm now speaking to you from Brunei.
Right.
I've been here for about 25 years. And before coming here, I was in Sri Lanka for a short spell and then again in Nigeria. So my expertise is mainly in civil engineering, roads and sewerage and structures. And I have been handling many projects starting from about $200 million to about $5 million. So at the moment, I'm just about to finish one project where I handled a project of about $55 million and coming to a conclusion. In the process, I was able to design some software, perhaps the first of their kind in the world, for pipe flow design, pipe flow sewerage design, something like SewerCAD. I don't know whether you all are familiar. Maybe civil engineers will know. So it's very nice. I'm very thankful to Chaminda for organizing this event. And this is the type of thing we should have, and all our engineers and other experts should join and, get together and keep our flag flying. Thank you.
Okay, thank you, Aloysius. Actually, I have been keep on telling people that this is not just for engineers, but the word system engineering, maybe they are afraid to join. Otherwise, I communicated this as a way of even sharing knowledge in project management, design thinking, and team building, multicultural, multicultural management. But I see still dominantly engineering group, but that's still it's all right. So let me introduce Greshan Fernando. Dr. Greshan is connected from Seattle, USA. He's one of our co-founders of FabLanka and director. So Greshan, since many people know you, but you can briefly introduce yourself, and also you can introduce Thiwanka to hand over. So thank you.
Yeah, thank you, Chaminda. So I'm Greshan Fernando, joining you from Seattle, Washington. And as Chaminda mentioned, I'm a founding member of FabLanka. And currently I work as a process engineer for Boeing Company. And my area of expertise at Boeing is product lifecycle management. And also we do a lot of systems modeling actually these days. So the systems engineering is a very, although I don't have a degree in systems engineering because my bachelor's degree is in manufacturing engineering, and then my master's and PhD are in mechanical engineering. But then after I joined Boeing Company, I got to involve with a lot of systems engineering groups, and I had the privilege of learning systems engineering, and I kind of, I understood it as like a very useful for anyone to do this kind of systems thinking actually. So with that, so I would like to introduce our speaker today. And so our speaker is Mr. Thiwanka Samaranayake, and he is also a systems engineer at Boeing Company here in Seattle. And he was actually very instrumental at the beginning when we formed the FabLanka. I had many discussions with him even before incorporated FabLanka in Sri Lanka. And then he continued to work with us on many things related to FabLanka. So while he's visiting Sri Lanka, I asked him to go to the FabLab that we started in Makandura and deliver this talk. So some education background about Thiwanka is that he has a bachelor's degree in material science and engineering, and then currently he's pursuing a master's degree in electrical engineering at University of Washington. So without further ado, let me invite Thiwanka to deliver today's talk.
Thank you, Gracious. Yeah, thanks for the good introduction. So I think you guys can all see this, the slide presentation that we developed for a discussion on systems engineering. So without further ado, I think I'll get started. The first slide is, next slide.
You want to share the screen?
Oh, Thiwanka.
You can share.
So you're not.
Yes.
You're not sharing it properly. We can see like the notes as well.
Right.
It's not the.
No, he can share the screen. It's better, not the multimedia.
I know. Yeah, he's fixing it. Yeah.
Is he going to share the screen?
Is that better?
Now it's good.
Yeah.
Is that better?
Yes.
No, I'm asking. Are you going to share the screen in Zoom? Do you have difficulty, or we can share it?
No, he's sharing now. Don't you see it?
No, I don't see it. Anybody?
I see it now.
I can see it.
I can see the background multimedia screen.
No, he's sharing the screen now.
So I'm not sharing my mic on my laptop. It's on someone's laptop.
I can see.
Anybody see? Because it doesn't get recorded here. Let me check.
I can see.
I think everyone see. Chaminda, you're not seeing that.
You have to you have to flip the screen.
Okay. Just because it should be recorded here. That's the problem. Otherwise, it doesn't matter to me. Right, screen. This is Supun screen, huh? The problem is now you are connected to Supun screen.
Right.
Yeah, Supun screen. Yes.
Anyway, it's okay. Go ahead. I'll figure out. But it's okay. Go ahead.
Everybody else see it, right? Everybody else see the screen, right?
Yeah, can see.
Okay, great. So, maybe you can go ahead.
Okay, so with this slide, with this cartoon, what we wanted to motivate.
Hold on. Okay, good. Okay.
Yeah, what we wanted to motivate you guys to think about is a holistic approach. So as you can see, there's 4 people in the boat. 2 people are drowning, and the other 2 are saying, "I'm sure glad the boat isn't on our end." And that kind of thinking isn't very helpful for actually everybody, because at the end of the day, the whole boat will sink, right? So it's very short-sighted and isn't helpful. So whether we like it or not, we're all in this together, and that's the kind of mentality that systems thinking is all about. So let's go on to the next slide.
That's good. I can see now it's recorded. Thank you.
So what exactly is systems engineering? So what we hope to do is give you a brief introduction to this, and I'm sure some of you guys already know a lot about this. So systems engineering is an interdisciplinary collaborative approach to derive, evolve, verify a life cycle balanced solution that satisfies customer needs. So what does that mean exactly? So systems engineering is multiple disciplines working together to develop, design, implement, and manage complex systems. Systems engineers, what they tend to do is they break down complex tasks into simpler ones that are more manageable to do. They also create tools and also try to, and through those tools, maintain those complex systems. They typically use iterative processes and collaborative thinking to build organized models for maintaining these complex systems. So systems engineers use what we call systems thinking. So what is systems thinking? It's a generic problem-solving process that uses methodologies and tools for identifying, evolving, and developing a product or a service for a need. And they think about questions, problems, or conditions as a system. Different components working together whose interaction is greater than the sum of the individual components. So if you want to, what do we mean by that? If you want to find a solution to an issue happening between two components of a system, it's not enough just to look at those two components, because you'll miss key details that will influence those two components. However, if you look at the broader system, the whole system, you can hone in on the sphere of influence around those two components, identify what's going on with the interaction between those two components and the system, and study exactly what's going on within those two components. It's sort of a way of helping people see the overall structure, patterns, and cycles in the system rather than seeing specific elements or events. And what that kind of thinking does is it allows for a solution that simultaneously addresses different problems within a given system. So let's go on to the next slide. So I touched on this briefly in the previous slide, but now let's get into the specifics of why systems engineering is important. So systems engineering, whether it's a complex or a complicated problem, can be simplified. Even if you don't know the specifics of each of the components or the elements within that system, you can simplify a bigger problem down to components. And of course, this type of thinking isn't just applicable in industry or or just in engineering. It can be used and applied in everyday situations as well. And systems engineering verifies the product or services and make sure that they meet the standards that is required. It's easier to solve a complex problem by breaking it down into its constituent parts. For example, if I asked you, hey, can you build me a plane? That's a huge monumental task. However, if I said, hey, can you build me an airplane seat? That's a much simpler problem much simpler task than building a whole airplane. So it's difficult to develop expertise for developing a whole plane. However, it's easy to develop expertise for developing a seat, right? So this type of holistic approach, what it does is you tend to look at all the stakeholders and it eventually becomes a win-win situation for everybody because you try to address everybody's needs. Next slide. Let me know if I'm going too fast Okay, so why is systems engineering, one more back. Why is systems engineering important? So systems engineering can transition new technologies into a product or a service. Especially in places where those technologies might not exist currently. And it integrates the inputs of an entire community and all its disciplines into a coordinated effort. And this is what I was talking about with the win-win situation, because we think about problems in a holistic approach, you try to address the needs of all the stakeholders. And because of that, it's a win-win situation. And systems engineering is used from the very beginning of the development of a product to the eventual retirement of the product. And it's used in lots of different industries. So we're going to get into that a little bit more now. Next slide. So what are the applications for systems engineering? So systems engineering is used in a multitude, actually probably everywhere, in terms of industry is concerned, from aerospace to civil engineering to software design. And like I was saying before, from the very beginning, from the research R&D phase of a project, all the way to retiring and maintaining a product, systems engineering is what manages that whole life cycle of that product. And I actually worked previously, before I worked at Boeing, I worked for a supplier to Boeing. They were called BE Aerospace. And the systems engineer, I worked closely with those system engineers, make sure that our product met the standards. So what they did is interpret the requirements set out by Boeing and the FAA, And they set up a structure for validating the product design through testing, because in aerospace, testing through validation through testing is the norm. And of course, the majority of the testing was environmental, flammability, and mechanical, because we were an interiors company. And systems engineers were the bridge that resolved the gap between the design of the product and the validation testing. We call that certification in aerospace. So they needed to have a deep understanding of the design and the requirements set out by the different regulatory bodies. So now, currently, as a systems engineer at Boeing, what I work on is looking at reliability data for different components within an aircraft and ensuring that wherever that aircraft flies, they will have all those parts that are most likely to fail ready at hand. And that type of holistic thinking is what systems engineering is all about. And it's, so like the slide says, it's the glue that holds it all together. So these are some examples, and none of these products are even possible without systems engineering, because they're so complicated and they interface with so many different parts. They all were built with systems thinking and systems engineering in mind. You can see there's these are lots of aerospace and space systems, 787, F-18, the shuttle programs. So all of these are built with systems thinking. Next slide, please. Okay, so systems engineering in aerospace. I'm going to get into this a little bit more now. Systems engineering is used quite a bit in aerospace, like I talked about. In a couple of slides ago, you probably saw a V-shaped diagram where it showed the whole design process from R&D to the eventual retirement of a program. So as a supplier to Boeing, in my previous company, what we did was work on the design and certification process. And currently, which is sort of the beginning of the life cycle of a product. And then right now, what I work on is maintenance and logistics engineering for Boeing, which is sort of the end of the life cycle of a product. And between from the very beginning to the very end, systems thinking is needed and is very much a useful tool for maintaining a product. Next slide. So now we're going to get into a little bit more technical details about systems architecture. So what do we talked a lot about complex systems and managing complex systems through systems engineering. So what do we mean by that, and how does that work? So systems architecture is a conceptual model that defines the structure and the behavior of a system. It relates the form and function of a particular system. And it's the way that physical and informational function is related to the different elements within a system. So let's get into that a little bit more, and I'll give you an example. So next slide. So here's a telemedicine system architecture sort of mapped out in very brief fashion.
Just a reminder, we have about 4 minutes. So once you disconnected, please come back to the same URL. Please go ahead.
Okay. Okay, sounds good.
So it's the same meeting ID and everything.
Okay. So in this telemedicine systems architecture, the overall function of the system is to analyze the patient's condition and to provide reports to healthcare professionals. So you can see that on the very right-hand side, there's the healthcare professionals and family, and in the middle, there's a patient. So the end goal of this system is to provide information to healthcare professionals and family about the patient. So in order to do so, the patient is providing information through the different sensors. You can see there's a line that says patient activity and sensor data. So information about the patient is provided through those sensors, like for example, blood pressure and sugar in the blood. All that information is provided to a central controller, which then go back. which then from that central controller, that information is disseminated into the web server and the caretaker's interface, from at which point they can access that information. And the idea behind this is, this kind of thing is a fairly new concept, but this kind of shows you the structure and the behavior of the different elements within this particular system. So before we go on to the next slide, should we, since time is running out, should we join at the other link, or what do you guys think?
We can try one more slide, or we can get some questions.
I'll try one more slide since I have about 3 minutes.
Okay.
Okay, so the next slide.
I think if anyone has a question, it's a good time, I think.
Yeah, that's a good point. If you guys have any questions.
Oh, one question.
Did you say there's a question?
No, I think.
I have a question.
Yeah.
Go ahead.
I'm Dimutu.
Yes.
Is it useful to people like marketeers like myself, marketing?
Absolutely. I mean, so, you know, systems engineering is all about maintaining a system, right? A complex product. So if, for example, if you take an airplane, right, the 787, in order for that to be successful, ultimately somebody had to sell it, somebody has to buy it, right? And all those, you know, now it's a much broader sense in terms of, it might not fall within the realm of engineering per se. However, in terms of maintaining a complex system, those types of things are also important, right? Because I mean, if somebody doesn't buy the product, you know, and it's not marketed well, you know, I mean, no matter how well the product is designed by the engineers, it's ultimately, you know, sitting on a shelf or, you know, sitting in a hangar. That systems in this kind of thinking, you try to integrate all the different components. I'm mainly focusing on the engineering side, but you're absolutely right. There is a much broader systems thinking that is involved in the successful implementation of a product.
Okay.
Thank you.
Yeah. So let's disconnect now and then reconnect back. If there are any problems of reconnecting back to the same meeting, we will try to get you one by one. If there's a new one, but most probably we will have the same URL, same meeting. So try to get into that. Okay. See you soon.
Okay.
Okay.
How many minutes have we have? Stand by.